Okay, from the second activity, I have frozen the calcium hydroxide solution from, not frozen, but I have cooled it from the first experiment. Next, I'm going to add exactly 0.18 grams of the eggshell, which is the calcium carbonate. Okay, I didn't mention before, but the weight before adding the eggshells was 124.60, and now it is sitting at 124.73. Okay, and now I add the 0.1 molar solution of the hydrochloric acid to our calcium hydroxide and calcium carbonate solution. Okay, here we go. Okay, I've used 5 milliliters so far. I'm going to get another syringe. Okay, adding to this as well. Beginning to see the color change. Okay, and there we go. Let it sit for 20-30 seconds just to make sure. There's approximately 2.2 milliliters of solution remaining. We used one entire syringe. This would be the second one. So we used approximately 7.8 milliliters. Okay, we're going to check the pH. Okay, so it's going to be about 4. Maybe we should go a little bit more. Continue. Okay, I didn't record it, but I ended up using a little more of the HCl in order to get the pH level that I needed. Okay, so we want to move on to the moles of HCl. So we just move over here. We had a 0.1 molar solution and multiplied that by the amount delivered, 8.8 times 10 to the negative third, and we got 8.8 times 10 to the negative fourth moles of HCl, which is equivalent to the proton value. And then we just see here, write out the equation. The calcium hydroxide plus the hydrochloric acid goes to calcium chloride plus water. Now if we just expand that equation, we break it down by ions. We go all the way, however the H2O does not break down. Then we can go on to cross out the like terms, which is the calcium and the chlorine, and we are left with this equation here, which is the 2 OH ions and the 2 hydrogen ions goes to water. As we can see here, the hydrogen and the hydroxide are in a 1-to-1 ratio. So therefore, the hydroxide is also 8.8 times 10 to the negative fourth moles. We want to convert that to molarity. So we just take that value, divide it by the amount of solution that we had, which was 5 milliliters. And next we get this value, the 0.176 molarity, the hydroxide. So we go here to the ice table. You have your calcium and your 2 hydroxides. So they both start at 0 molarity. And then you add your X, and this one's going to be 2X since it's a 2-to-1. And we know that hydroxide is equal to 0.176. So we do 2X equals 0.176 divided by 2 And there is the final molarity, the molar solubility.